In an age dominated by information and technology, IT networking stands as the backbone of our modern world. Imagine a day without access to your emails, or social media, or even your favorite streaming platforms. A single day without IT networking could bring our digital world to a halt. That's how crucial networking is to our everyday lives. Diving into this fascinating world, we'll begin by exploring the fundamentals of networking. Networking, in the IT sense, is the practice of linking computing devices together, facilitating communication and data transfer. This digital interconnection is made possible through various components such as nodes, switches, routers, and cables. Networks take various forms, including local area networks, or LANs, and wide area networks, or WANs, each with their own unique advantages and disadvantages. Moving forward, we'll delve into the realm of network protocols and standards. These protocols like TCP, UDP, IP, ICMP, HTTP, and many others are essentially the rules that allow devices to communicate. They form part of larger frameworks like the OSI model and the TCP/IP suite. Standards, on the other hand, ensure compatibility and interoperability between different devices and are maintained by organizations like the Institute of Electrical and Electronics Engineers. Next, we turn our attention to network infrastructure. Here we'll discuss various network topologies, from the star and bus to the ring, mesh, and hybrid types. Each topology has its unique set of advantages and drawbacks. We'll also talk about key network devices like switches, routers, firewalls, and their roles in the network. And of course, we can't forget about network security. We'll discuss the importance of encryption, firewalls, VPNs, and intrusion detection systems in protecting your network. Finally, we'll shed light on network administration and management. We'll explore the roles of network administrators, the tools they use, and the protocols that aid in network management, such as SNMP and NetFlow. We'll also discuss common network issues and troubleshooting techniques, emphasizing the importance of network documentation and logging.
Welcome to our exploration of the OSI model. Let's dive into the first layer, the physical layer. The physical layer is the foundation of network communication. It deals with the physical connection between devices, defining specifications for cables, connectors, and hardware. Its primary role is to transmit raw data bits over a communication channel. It's responsible for converting digital data into signals that can be sent over the network medium. This layer ensures reliable transmission of data by managing signal timing, voltage levels, and physical addressing. It also handles error detection and correction. Components of the physical layer include cables, connectors, network interface cards, NICs, and other physical hardware required for communication. In summary, the physical layer establishes the physical connection between devices, ensuring efficient and reliable data transmission across the network. Stay tuned as we explore the other layers.
Welcome to our exploration of the OSI model. In this segment, we'll delve into Layer 2, the data link layer. The data link layer is crucial for ensuring reliable data transfer between directly connected devices within the same network. Its primary role is to manage data traffic by providing mechanisms for addressing, framing, and error detection on the physical layer. One of the key functions of the data link layer is to encapsulate data into frames, adding header and trailer information for transmission. It also uses MAC, Media Access Control, addresses to uniquely identify devices on the network. One common example of Layer 2 technology is Ethernet. Ethernet operates at the data link layer and uses protocols like Ethernet 2 or IEEE 802.3 to govern data transmission over wired networks. Another example is Wi-Fi, which operates wirelessly at Layer 2. It uses protocols like IEEE 802.11 to enable communication between wireless devices within a local area network, LAN. MAC addresses, or hardware addresses, are another example of data link layer concepts. These unique identifiers are assigned to network interface cards, NICs, and are used for addressing and communication within Ethernet networks. In summary, the data link layer ensures efficient and reliable data transfer between devices within the same network. It manages framing, addressing, and error detection, enabling seamless communication. Join us as we explore more layers of the OSI model.
Ever wondered how data packets find their way across networks? Well, the hero of the day is the network layer, the third layer in the OSI model that takes on the responsibility of ensuring that these data packets navigate the network labyrinth to reach their intended destination. The network layer is the postmaster of the network world. It deals with logical addressing and routing. It's like the GPS for data packets, calculating the most efficient route for the data to reach its destination, irrespective of the physical network layout. At the heart of the network layer's operations is the encapsulation of data into packets. Think of these packets as parcels, each carrying an address, the IP address, which guides them to their destination. The network layer also takes care of breaking down larger packets into manageable sizes and reassembling them at the destination. It's quite the multitasker, isn't it? The Internet Protocol, or IP, is one of the most widely recognized faces of the network layer. It's the protocol that assigns unique IP addresses to each device on a network, making sure that every data packet has a clear destination. But the IP isn't working alone. It's got a team of routing protocols such as OSPF and BGP that help build routing tables and exchange routing information. These protocols ensure that the data packets are delivered efficiently, even across vast networks. And then there's IPv6, the new kid on the block. IPv6 is the long-awaited upgrade to IPv4, providing a much larger address space to accommodate the ever-growing internet and support emerging technologies. So to wrap it all up, the network layer is the unsung hero working behind the scenes to ensure smooth communication between devices across different networks. It's all about logical addressing, routing, and packet forwarding. Without it, the internet as we know it would cease to exist. Stay tuned as we continue to unravel the mysteries of the OSI model layer by layer. And while you're at it, why not join our TikTok community for more exciting content and behind-the-scenes peeks into the world of networking?
Welcome to our deep dive into the transport layer, the fourth layer of the OSI model, where data transmission takes a sophisticated turn towards reliability and efficiency. The transport layer is tasked with pivotal roles, including segmentation and reassembly of data blocks into smaller units for easier network handling, and establishing a reliable connection between sending and receiving devices through a process known as a handshake. Here, we witness the duality of the transport layer. On one side, protocols like TCP ensure a reliable, ordered data transfer through connection-oriented communication. On the other, UDP prioritizes speed and efficiency, offering connectionless communication ideal for streaming and gaming. Data integrity is non-negotiable. Through error detection and correction mechanisms like checksums, the transport layer makes sure every bit of your data arrives as intended, retransmitting any segments that don't make the cut. To prevent data traffic jams, flow control measures adjust the data transfer rate between sender and receiver, ensuring that the receiving device isn't overwhelmed by the sender's speed. Lastly, the transport layer manages traffic through ports, guiding data to its rightful application destination. Whether it's your emails, web pages, or video calls, port management ensures your data arrives exactly where it's needed. In summary, the transport layer is the cornerstone of reliable, efficient, and orderly data communication across networks. It's what makes our digital world tick, ensuring that every piece of information reaches its destination intact and on time. Thank you for joining us on this journey through the transport layer. Stay curious and continue exploring the fascinating world of networking.
Dive into the world of network communication with us as we explore the session layer, the fifth layer of the OSI model, where the magic of session management, establishment, maintenance, and termination unfolds. At the heart of the session layer lies its critical role in managing dialogues between applications. It's where sessions are born, lived, and concluded, facilitating communication over a network with finesse and precision. Imagine reaching out and shaking hands before a conversation. That's the session layer establishing a connection. It sets up the dialogues, ensuring applications on both ends are ready to engage. Once a connection is made, the session layer keeps the conversation going. It manages the exchange, maintaining the session's integrity and ensuring that communication flows seamlessly. All good things must come to an end, and so must network sessions. The session layer is responsible for gracefully closing connections, ensuring all communication is neatly concluded before both parties part ways. The session layer also governs dialogue control, managing who speaks when in a full duplex or half-duplex communication setting, making sure that messages are exchanged in an orderly fashion. It introduces checkpoints and data streams for synchronization, allowing for the recovery of information in case of disruptions, ensuring that no data is lost in the ebb and flow of digital communication. To wrap it up, the session layer is the unsung hero that orchestrates the symphony of network communication. It ensures that sessions start, proceed, and end with precision, making our digital interactions possible and reliable. Thank you for joining us to uncover the essentials of the session layer. Keep exploring with us and unravel the mysteries of networking layer by layer.
Ever wondered who the digital world's interpreter and guardian is? Meet the presentation layer, the sixth level of the OSI model, where data is transformed into a form that's both comprehensible and secure. The presentation layer is a polymath, fluent in the language of data. It's where data gets translated, encrypted, and compressed, preparing it for transfer or making it understandable upon receipt. Picture this. Data translation at the presentation layer is like being the Rosetta Stone of digital communication. It converts raw binary data from the application layer into a format ready for transmission and back into a user-friendly form upon arrival. In the realm of digital dialogue, privacy isn't just a luxury, it's a necessity. The presentation layer ensures this by encrypting data before it's sent and decrypting it upon arrival. This means that your conversations remain for your eyes only. Efficiency is a key driver in the digital age. The presentation layer embodies this by compressing data, reducing the size of the data being transmitted. This speeds up transfer times and saves precious bandwidth, but the presentation layer doesn't stop there. It also shines in managing complex data structures. Whether it's dealing with multimedia formats or juggling different data representations, it ensures that the data is in the perfect format for the application layer. So, to sum up, the presentation layer is the digital world's interpreter and guardian. It transforms, protects, and optimizes data so it can travel securely and efficiently across the network landscape. We thank you for joining us on this exploration of the presentation layer. Stay curious and continue your journey through the vast and vibrant world of networking.
Ever wondered how your emails get sent or how your browser fetches web pages? Welcome to the fascinating world of the application layer, the topmost layer of the OSI model. This is the gateway where user-focused software and network services converge to create a seamless user experience. The application layer is the stage where your software applications access network services. Whether you're sending emails, browsing web pages, or transferring files, it all happens here with just a click or a tap. Now, this layer isn't working alone. It houses a suite of protocols, including HTTP for web browsing, FTP for file transfers, and SMTP for email. Each of these protocols ensures that your data is communicated efficiently and reliably across the network. But the application layer isn't just about protocols. It provides the interface for user interaction, translating complex network processes into simple, intuitive actions. Whether you're on a smartphone, tablet, or computer, the application layer ensures you have a smooth, user-friendly experience. From streaming your favorite show, playing online games, to storing data in the cloud, the application layer brings a multitude of services to life. It's the enabler of the digital experiences we've come to rely on daily. In the modern digital ecosystem, the application layer also embraces APIs and network virtualization. This facilitates innovation and integration across platforms and services, making technology more adaptable and scalable. In conclusion, the application layer is the interface between humans and the complex world of networking. It's the final frontier where technology meets usability, driving the digital age forward. Thank you for journeying with us to the peak of the OSI model. As we've seen, the application layer is not just about applications, it's about possibilities. So continue to explore, keep learning, and keep innovating. The future is bright and it's connected. Before we wrap up, we want to remind you to hit that subscribe button and give this video a thumbs up if you found it helpful. Your support helps us bring more informative content like this to the digital world, breaking down complex concepts into digestible bits. Remember, the more likes and subscribes we get, the more content we can produce. So if you found our journey through the application layer insightful, show us some love. Stay tuned for more content that will keep you at the cutting edge of technology. Thank you for watching.